Hello class, in this video we discuss how to fit a data set to a mathematical formula using Desmos. So what you're seeing on the screen right now is a data set similar to what you were assigned in the very first project with influenza-like illness. There are two columns of data here, and the first column denotes time steps in steps of weeks in the calendar year, and the second column has measurements of counts of influenza-like illness. So what we need to do is locate this file that you put together, copy all the data set, and then paste those two columns of data into Desmos. So once I copy and paste this into Desmos, there are two columns that are created. Automatically Desmos labels the first column X sub 1 and the second column Y sub 1. You can see here the full data set has more than 500 measurements. So in this case there are 534 more than 500 rows for sure. So if I choose to select there the next to Y1, I can select or unselect, and then we see a display of the observations, the measurements of the data. This is what you had previously done. So what we will do next is that we are going to assume a formula which is sinusoidal. So there are two possible formulas here that we can work with. Let me go and show you. So the syntax is that we are going to represent the column that stores the ELI measurements, y sub 1. It's almost as writing y sub 1 equals, but instead of the equal sign, we use the tilde. Typically, the tilde in the keyboard is below the escape keystroke. And we write this form, A cosine plus D, this is the vertical shift, and the argument of the cosine function has B times something minus C. So A, B, C, and D are parameters, and here instead of calling this X, we call it X sub 1 because that's the name of the first column of the data. So once we type this, then Desmos automatically computes estimates for A, B, and C, which are reported there. I'm going to select this, and we see how a curve here appears kind of going through the data. We could use the other sinusoidal form, the other sinusoidal function with sine instead of cosine, but the same parameters and the same syntax where we're saying y sub 1 tilde, and on the other side we write the sine function, and then Desmos carries out the computation. Now if I select this, then it appears, and another curve appears with a different color. So it is for you to decide which of the two functions you will explore. You just have to choose one and stay with that one. But in either scenario, the question you should be asking is this a good fit? So this is a terrible fit, okay? But you are going to first do an exploration with your full data set, and then just by visual inspection, you're going to decide on, look, here's the data set, I'm going to select subsets, okay? So I'm going to show you two subsets that I selected by visual inspection. You could use this these icons here on the kind of right edge of the graph. There is the graph settings, and there is the zoom in and zoom out options. But using a little bit of that, I decided to go with a subset in two different. So it's basically selecting a shorter version of the two columns. So I started a new graph. I copied and pasted the subset. You can see that this is about 200 rows of data, and these are observations between 2010 and 2014. And now I'm going to explore what happens if we use a cosine function as the description of this data set. And you can see a much better agreement in certain parts of the data set, as if we were using, instead of contrasting this to the case where we use the full data set. So very importantly is that from these parameter values, I could compute something, for example, like the period, or the frequency, or things of that sort. Here is another subset of the data with observations between 2015 and the end of 2017. And if we explore the cosine function again, then you can see that the best fit graph is in agreement in certain parts, and very importantly, we obtain values of the parameter.